This lesson, you'll be able to determine whether a point lies on a line. You'll also be able to find a coordinate of points that lie on a line. If a point lies on a line, it satisfies the line's equation. That is, the left-hand side equals the right-hand side of the equation when the coordinate of the point is substituted into the equation of the line. A first problem. Determine whether or not the following points lie on the line. We substitute for the point P, the 4 is the x coordinate, the minus 8 is the y coordinate. So we are given the equation y equals 43 minus 12s. We are substituting the point P 4, minus 8. In place of the y, we substitute minus 8. We substitute 4 for s. Minus 12 multiplied 4 gives minus 48. The right hand side gives us minus 5. We see that the left hand side is not equal to the right hand side. So what it implies is that the point P 4, minus 8 does not lie on the given line. Does not lie on the given line. So this for question A. Now we solve question B. Question B, we want to substitute the coordinates 5 divided 3, 23 into the equation y equals 43 minus 12s. In place of y, we substitute the y coordinate 23. We substitute the s coordinates 5 divided by 3 for s. Minus 12 multiplying this fraction gives us minus 20. 20 from 43 gives you 23. For this example, we see that the left hand side equals the right hand side. So what it implies is that the point N lies on the given line. It implies the point N lies on the given line. Next question. Now, what we should notice is that if a point lies on a line, you can substitute the coordinates of the point into the equation of the line. That's all we have illustrated in the diagram. In the diagram, we have coordinates s1, y1. We see that the very s1 here in the coordinates is the very s1 here in the equation of the line. The very y1 in the coordinates is a very y1 in the equation of the line. So once the point lies on the straight line, we substitute the coordinate of that point into the equation of the line. Problem 2 is an example. We are told that the point minus 5, p lies on the line 3y minus 2s minus 18 equals 0. Find the value of p. We are substituting a point into the equation of the line. In place of y, we substitute the y coordinate p. In place of s, we substitute the s coordinate minus 5. So we get 3p plus 10 minus 18 equals 0, which in turn gives 3p minus 8 equals 0. When we divide both sides by 3, we get p to be 8 divided 3. So this is the value of p. It tells us that the coordinate minus 5 comma p is equal to minus 5 comma 8 divided 3. That's what it implies. The next question. The line intersects the x-axis at minus 6. Find the value of k. At the x-intercept, the y-coordinate is 0. So we have the coordinate minus 6, 0, which lies on the line 4s minus 3y plus 6k equals 0. Finding the value of k, we substitute the coordinate minus 6, 0 into the equation because we are told it lies on it. So 4 multiply the x coordinate minus 6 minus 3 multiply the y coordinate 0 plus 6k equals 0, and that gives minus 24 plus 6k equals 0, which in turn gives 6k equals 24. Dividing both sides by 6, we get the value of k to be 4. So that's for I. Question II. We are to determine the gradient of the line. Now the equation of the line becomes 4s minus 3y plus 6. Now the value of k has been solved for. The value of k is now 4. So the equation of the line becomes we are to find the gradient. We have to find the gradient of the line. So what we want to do is to write the equation in the general form y equals ms plus c. We want to make y the subject. So we write the term that involves y minus 3y equals, subtract 4s from both sides. This is what we have. 6 multiplied 4 is 24. Subtract 24 from both sides. So rearranging this equation, we get this new one. Next, we divide every term by minus 3. Divide every term by minus 3 so that y is made the subject of the equation, just like this one, equation star. So now we get y equals 4 out of 3s plus 8. So comparing equation star to equation alpha, we see that the value m is equal to the gradient m is equal to the value 4 out of 3. This is the gradient of the straight line. So we are done solving question II. If we are asked to write the y-intercept, the y-intercept c is equal to 8.